Okay, so today we're going to be looking at topic 2, which is all about absolute value functions. Essentially what an absolute value function does is we use these vertical lines and we say that inside of these lines we will put x. It's kind of like parentheses, and we say that the absolute value of x makes everything positive. So the absolute value of any number can only be positive or 0. So it's either positive or 0. This is the most important part about them. You will always get a positive number out. For example, if you type in f of positive 4, nothing happens. You will just get 4 as your output. However, if you input negative 4, it will change the sign to positive. So only positive numbers can come out of the absolute value function, and this is exactly how it works. Here's one more example. If we do f of 207, nothing happens because this is positive or 0. However, if we input f of negative 31, we will just get 31. So it switches the sign whenever you plug in a negative. That's essentially all it does. Let's look at how this applies to equations. So solving equations, we know we have options like dividing both sides by 2 on this example, and we get x is equal to 4, and we get one answer. Okay, so one solution. However, whenever you have an absolute value, you have two different scenarios. You could have the first scenario where if you plug in 8 to the absolute value, you get 8. So the first scenario would be 2x equals 8, in which x is equal to 4 like we just saw. However, there's another possibility. If we plug in negative 8 into the absolute value, we will also get 8. So there is a different scenario where 2x is equal to negative 8. Okay, if we solve this equation, divide both sides by 2, we get a different solution. X is equal to negative 4, and we have two solutions this time. Two solutions. So absolute values can have more than one. How this looks on a number line essentially is, and this is the key point I want you to take away, the absolute value of any real number x is this distance from 0 on the number line. So for example, on this one, we have 0 on the number line. We had one solution at negative 4 and one solution at positive 4. Okay, both of these will output the same value since we're multiplying by 2. So that's the basic idea of how you want to think about this. Your two solutions would be 2 points on this graph. But for this example, it would just be 1 point at 4. So one solution. Okay, let's try another example. I'm not going to do all of these examples. Just make sure you know that at the end of this video, make sure to stick around. I'm going to be showing you the super top secret Desmos hack to solve these equations on Desmos. But for the time being, we're doing this purely algebraically. Two scenarios. Scenario 1, either 2x minus 1 is equal to 5, so nothing changes. Or scenario 2, maybe 2x minus 1 is equal to negative 5, because that is the other case scenario that we have to worry about. Okay, so positive and negative. Okay, we're going to solve these pretty much the same way, so we might as well do them at the same time. We're just going to add 1 to both sides. Put my line here to keep my algebra organized. To cancel off the 1 on the left sides of both of these equations, we get 6. And over here on example 2, we get negative 4. Okay, divide both sides by 2. On the left here, we get x is equal to 3, which is one of my answers. And on the right, we get x is equal to negative 2. Okay, so two different solutions. Once again, two different solutions. Okay, example 3, I will leave up to you. You know what? I'll do example 3 with you. Let's see. To do example 3, you cannot consider the two scenarios until you get the absolute value by itself. Okay, so you'll notice we have this plus 4 here. We are going to want to move that over first, just so we can start with x plus 2, absolute value, is equal to 4. Okay, so this will be our situation where in the first example, we have x plus 2 equals 4. No big deal, x equals 2. And the second scenario where x plus 2 equals negative 4, in which case x would have to be negative 6. Okay, so it's all about looking at both of those scenarios. Okay, now something interesting can happen whenever you try to say things that are not true. So like, for example, if I try to say that this equals 0, if I subtract 2 on both sides, I get absolute value of x plus 6 is equal to negative 2. And this makes no sense. Okay, we know that the absolute value of any number has to be greater than or equal to 0, so there's no possible way that this is true. This is false. It will never equal 0. And later on Desmos, I'll show you what that means graphically. On the other example, we would add 2 to both sides if we set it equal to 0, and we would get absolute value of x plus 6 equals 2, which does have reasonable solutions. And I'll let you find those on your own. So we have both scenarios. Make sure to do both. I'm going to let you find these on your own, and you should get 2 values of x for your final answer. Make sure to do those on your own. Okay. Once again, just like all my Algebra 2 videos, feel free to pause at any time to catch up on notes. Okay, let's see. The last one we're going to do is right here. Example 6 is going to be a challenge for you to complete on your own. But example 5, we're going to talk about extraneous solutions. Okay? Sometimes the answers are just wrong. Okay, so you have to check. Sometimes the answers are just wrong. And I know that is just the most annoying thing ever, but it's just something you have to deal with in Algebra 2. Sometimes the answers are just wrong. So you have to check. You have to check. Okay, and you better believe on your next test, they will be testing your ability to know that. Okay, what we have here is an absolute value function. Okay, and we still have 2 scenarios. Scenario 1, either 3x plus 2 is equal to 4x plus 5, or scenario 2, 3x plus 2 would be equal to the negative version of that. So in this case, that would be negative 4x plus 5. Okay, once again, the only difference between these two is that we are making it negative on example 2. For scenario 1, we would try to get all my x's together. So I'm going to subtract a 3x on both sides to get 2 is equal to x plus 5. If we subtract 5 on both sides, we get x is equal to negative 3. Okay, I'm not going to circle this answer because I do not know if it works yet. Okay, I'm going to emphasize that. I'm not going to circle this answer because I do not know if it works yet. Okay, we will have to see whenever we check. The next one. If we have this equation, we need to distribute the negative. So this would be negative 4x minus 5 on the right side. It's going to be about the same steps though. Let's see, I'll subtract a 3x on both sides just to get them together. So 2 is equal to negative 7x minus 5. Okay, and then I'm going to add 5 to both sides to get 7 is equal to negative 7x. This leads me to the solution x equals negative 1. Okay, so we have 2 different solutions. We have x equals negative 3 and x equals negative 1. We have to test them both. Okay, the way we do this is by plugging it into the left side and the right side. Okay, in my first solution, if we plug in negative 3 to the left side, we get absolute value of 3 times negative 3 plus 2, which is equal to, let's see, 3 times negative 3 would be negative 9 plus 2. Negative 9 plus 2 would be negative 7, and the absolute value of negative 7 would be positive 7. Okay, on the right side, we get 4 times negative 3 plus 5, okay, which is equal to negative 12 plus 5, which is equal to negative 7. Okay, so what you can see here is that the left does not equal the right, which means that negative 3 is extraneous. Okay, and yes, you have to check them both. I will spoil it here though and say that if you do check the left and right side when you plug in x equals -1, you will find that this solution does work and that the left side will equal the right side, but I'll leave that up to you. Example 6 is also up to you, so I will leave that for your own enjoyment. Okay, example 7. In a speech class, students must give a final speech for their exam. The speech can be 15 minutes or within that time by 4 minutes. So the way to think about this is the allowable times are going to be within 4 minutes of the 15-minute mark. So that would be 19 minutes at most and 11 minutes at least. So we're looking for those two solutions, 11 and 19. You do have to try out every single one. If you try out answer choice B, you will get two scenarios. Either t minus 15 is equal to 4, in which case t is equal to 19, or scenario 2, where t minus 15 equals -4, in which case t would be equal to, 11, which is exactly what we want. Okay, you do have to try out every single one though. On Desmos, this is much easier, but once again, you'll have to stick around after example 8, and I will tell you exactly how to do that. Actually, I'll tell you what, example 8 will be just for you. So right now we're gonna head over to Desmos, and I'm gonna show you exactly what that looks like. Okay, so on Desmos, all you have to do is type in your equation where y equals the left side and y equals the right side of the equation. And when you do this, essentially, when you type this in, you will get two lines on the graph that will cross each other once or maybe twice. Like we said, we have one solution and two solutions in this set. And if you do that for every single problem on this entire paper, you will find every single answer that we have already gotten. Here is example 3. Just looking at example 3 with the answers. Example 4, we remember that one of them was not able to equal 0. We can see that graphically. This one, there we have our one correct solution. The extraneous solution is not on there. And same with example number 6. I did not solve this one with you, but just letting you know that it's possible to do this on Desmos. Please know that you're able to use Desmos whenever you need to. And that if you prefer to do it by hand, that just means you're smarter than me. Okay. Have a great day. See you later. Goodbye.